Question 31 asks if x square plus y square equal to z square, show that z over del x equal to x over z and del z over del y equal to x over y over z. To find the del z over del z x from the given question, we need to differentiate with respect to the x. So we got 2x plus 0 equal to 2z dz over del x. Del z over del x equal to del x equal to 2x over 2z, also equal to x over z. Then we need to find the del z over del y. So differentiate respect to the y, and we got 0 plus 2y equal to 2z del z over del y. Del z over del y equal to 2y over 2z and also equal to y over z. Then the question asks for deduce that del square z over del x square plus del square z over del y square equal to 1 over z. So we need to differentiate second time. So y x over z differentiate in respect to the x by using Conseil rule, and we got the answer 1 over x. For question 32, show that u x y equal to ln x square minus y square. For x more than y, satisfy the equation del square u over del x square minus del square u over del y square equal to 0. So we need to differentiate u respect to the x. So we got del u over del x equal to 2x over x square minus y square, and differentiate is to second derivative, and we got 2y square over x square minus y square square, and same goes to the u respect to the y, and we got del u over del y equal to negative 2y over x square minus y square, and same goes to the previous. We need to differentiate second time, and we got 2x square over x square minus y square square, and the difference of the del square u over del x square minus del square u over del y square, it is equal to 0. For question 33, we need to find the possible value of n if the function u equal to x r power of n satisfy the equation del square u over del x square plus del square u over del y square equal to 0, where r square equal to x square plus y square. So we need to express the r, and we got r equal to r x square plus y square power of 1 over 2, and then sub the r into the first equation and do the and differentiate the equation. So we got del u over del x equal to n x square times x square plus y square power of n over 2 minus 1 plus x square plus y square power of n minus 2n over 2, and differentiate twice, and we same goes to del u over del y and del square u over del y square. Then to make it the equation satisfied, we rearrange and sub the value of del square u and del square u over del x square and del square u over del y square into the equation, and solve, and we got n equal to 0. For question 34, we need to find the function that satisfy the Laplace equation. For part A, we have function f(x) y equal to exponent power of x sin y plus exponent power of y cos x. Differentiate function respect to the y, and we got exponent power of x sin y minus exponent power of y sin x. We differentiate it twice, and we got exponent power of x sin y minus exponent power of y cos x. Same goes to the function respect to y, and we got exponent x cos y plus exponent y cos x. Differentiate it twice, and we got negative exponent x sin y plus exponent power of y cos x. Sub the value into the Laplace equation, and we got 0, and it is satisfied. For question B, the given function is fxy equal to ln x square plus y square. So we need to differentiate the function respect to the x and differentiate twice with respect to the x. Same goes to the function with respect to the y, and differentiate twice with respect to y. After that, we sub the value into the Laplace equation, and still we got 0, and it is satisfied. For C, we have function fxy equal to x over x square plus y square. So we need to differentiate the function respect to the x and respect to the y. After that, we differentiate it twice, and we got del square t, del square f over del x square, and del square t over del y square. We insert the value, we are following the Laplace equation, and it is satisfied. For question D, the function given fxy equal to inverse tan 2xy over x square minus y square. So we need to differentiate the function respect to the x, and we got negative 2y over x square plus y square. Differentiate the df over del x and simplify it until we got 4xy over x square plus y square bracket square. Same goes to the function that differentiate respect to the y, and we got 2x over x square plus y square, and differentiate it twice until we got negative 4xy over x square plus y square bracket square. Then we need to add the del square f over del x square plus with del square f over del y square to know that if it is satisfy the Laplace equation, and we got the 0, so it is satisfied. For the question 35, we need to prove that if u equal to x power of n fy, where y is equal to y over x and f is an arbitrary function, and x del u over del x plus y del u over del y is equal to nu. We need to differentiate the u respect to the x until we get fy n x power of n minus 1 minus f prime y x power of n minus 2. Same goes to the del u over del y. We get f prime y x power of n minus 1. Then we need to times the x with del u over del x. Same with del u over del y, we need to times y, and adding both until we get n x power of n fy, which is same with nu. And if z equal to x square tan negative 1 y over x minus y square tan power of negative 1 x over y. For part A, we need to differentiate the z equation respect to x, and we get 2x inverse tan y over x minus y. Then we differentiate the z equation respect to the y, and we get x minus 2y inverse tan x over y. Then we use the formula x del z over del x plus y del z over del y, and we get 2x square inverse tan x y over x minus 2y square inverse tan x over y. Also same with the 2z. For part B, we have the previous value of del z over del y, so we need to differentiate it respect to the x, and we get x square minus y square over x square plus y square, and it is proven. For the question 36, we need to satisfy the wave equation, which is del square u over del t square equal to c square del square u over del x square. So for the part A, the given equation u x t equal to x square plus c square t square. So we need to differentiate u respect to t, and we got 2c square t, while respect to the x we got 2x. Next we differentiate it twice. For the del square u over del t square, we got 2c square, while u respect to the x we got del square u over del x square, we got 2. So it is satisfied. For the part B, equation given u x t equal to x minus c3 cube plus x plus c t cube. So we need to differentiate the u respect to t, and we got 12c square dx. While differentiate u respect to x, we got 6x square plus 6c square t square. Differentiate the du dt, we got 12c square x, while differentiate the du dx, we got 12x. Then we compare, and it satisfies the wave equation. For question C, function given u x t equal to sin kct sin kx. First we need to differentiate the function respect to t, and we got kc times cos kct sin kx. And when the function differentiate respect to x, we got k sin kct cos kx. Differentiate the du dt, and we got negative k square c square sin kct sin kx. When differentiate the du dx, we got negative k square sin kct sin kx. Rearrange the function following the wave equation, and it is satisfied. For part D, the given function u x t equal to t over c square t square minus x square. So we need to differentiate function respect to the x by using the consine rule, and we got 2xt over c square t square minus x square bracket square. Same goes to the function du over dt, and we got negative c square t square plus x square over c square t square minus x square bracket square. Differentiate the du dt and du dx. For the del square u over del x square, differentiate it and simplify until we get 2t times c square t square plus 3x square over c square t square minus x square bracket cube. Same goes to the del square u over del t square. Differentiate it until we got 2c square t times c square t square plus 3x square over c square t square minus x square bracket cube. Rearrange the equation by following and satisfy the wave equation. For the question 37, the equation given y x t equal to fx minus 4t plus gx plus 4t. We need to satisfy the wave equation. Del square y over del t square equal to 16 del square y over del x square. So we need to let p equal to x minus 4t and q equal to x plus 4t. Differentiate p respect to x, and we got 1, and while p respect to t, we got negative 4. We got 1 when q respect to the x, and 4 when q respect to t. dy over dx equal to df over dp times del p over del x plus dg over dq times del q over del x, and we got df over dp plus dg over dq. Same goes to dy over dt, and we got negative 4 df over dp plus 4 dg over dq. We need to differentiate second time for y respect to the t. So we got del squared y over del t square equal to del over del t 4 times dg over dq minus df over dp, and we got 4 times del square g over d square dq square times 4 minus d square f over dp square times negative 4, and we got 16 d square g over dq square plus d square f over dp square. Same goes to y respect to x, but differentiate second time. When we got 1 over 16 d square y over dyt equal to d square y over dx square. So the equation is satisfied. For the question 38, we need to satisfy the function del u over del t equal to alpha square del square u over del x square. square. For the part A, equation given u x t equal to exponent negative a alpha square t sin x. So we need to differentiate respect to the t, and we got exponent negative alpha square t sin x. Same goes to du over dx, and we got exponent power of negative alpha square t cos x, and differentiate twice for the del square u over del x square equal to negative exponent power of negative alpha square t sin x. Rearrange the function and we satisfy. For the part B, the equation given u x t equal to 4 exponent power of negative alpha square cos t. So we need to differentiate respect to the t, and we got negative 4 alpha square exponent power of negative alpha square t cos x. Same goes towards u respect to x, and we got negative 4 exponent power of alpha square t sin x, and we need to differentiate twice for u respect to x, and we got negative 4 exponent power of alpha square t cos t, and we need to rearrange the equation, and same we still get del u over del t equal to alpha square del square u over del x square, and it is satisfied. For C, u x t equal to exponent power of negative alpha square t times 2 sin x plus 3 cos x. So we need to differentiate u respect to t, and we got negative alpha square exponent negative power of negative alpha square t times 2 sin x plus 3 cos x. For u respect to differentiate u respect to x, and we got e exponent power of negative alpha square t times 2 cos x minus 3 sin x. Differentiate u twice for the respect to the x, and we got exponent power of negative alpha square t times negative 2 sin x minus 3 cos x. Rearrange the equation, and same we got del u over del t equal to alpha square del square u over del x square. For D, the equation given u x t equal exponent power of omega square alpha square t sin omega x, when u differentiate respect to the t, and we got negative omega square alpha square exponent power of omega square alpha square t sin omega x. When u differentiate respect to the x, we got omega exponent power of omega square alpha square t cos omega x. When u differentiate twice respect to the x, we got negative omega square exponent power of negative omega square alpha square t sin omega x. We rearrange the equation, and we got del u over del t equal alpha square del square u over del x square. For the question 39, the equation given u x y z equal to 1 over square root x square plus y square plus z square, and need to be satisfied by 3-dimensional Laplace equation given. So we need to sub the r equal to square root x square plus y square plus z square, and let u go to 1 over r. So differentiate u, and we got del square u over del r square plus 2 over r del u over del r. Del u over del r, and it is equal to negative 1 over r square, while del square u over del r square equal to 2 over r square. Sub it back into the formula, and same we got 2 over r square times 2 over r square equal to 0, and is satisfy the equation that u x y z equal to 1 over square root x square plus y square or plus z square. For the question 40, we need to find the gradient of the curve of equation given when point x equal to 1 for using equation 2.16, which is dy over dx equal to del f over del x over del f over del y. The del f over del x is equal to 3x square plus y, while del f over del y equal to negative 4y plus x. So we got the dy dx equal to negative 3x plus y over negative 4y plus x. So sub y into the function, and we got y equal to 1 and y equal to negative 1 over 2. For using point 1 and 1, dy dx got 4 over 3, while for using 1 negative 1 over 2, we dy dx we got negative 5 over 6. For question 93, we need to find the dimension of rectangular parallel pipe of maximum volume with edges parallel to the axis which can inscribe in ellipsoid equation. The given equation, x square over a square plus y square over b square plus z square over c square equal to 1. First of all, we need to define the volume of the parallel pipe. So we have v equal to 2x 2y 2z or equal to 8xyz. Next, we need to use the Lagrange multiplier method, and we got Lxyz lambda equal to 8xyz plus lambda 1 minus x square over a square minus y square over b square minus z square over c square. Introduce the lambda, then we need to find the partial derivative and set them to 0. We differentiate all of them respect to z, respect to y, respect to z, and respect to the lambda respectively, and express the lambda from the equation and set them equal to each other, and we got 4yz a square over x equal to 4x zb square over y equal 4x y c square over z. We need to split into the two equations to make it more easier. For the first step, we compare yz a square over x with xzb square over y. Here we got a square over x square equal to b square over y square. For the second step, we compare the xzb square over y with xyc square over z, and we got b square over y square equal to c square over z square. Then we use the constant to constrain and solve it and make it more easier. Then we assume a square over x square equal to b square over y square equal to c square over z square is equal to k. Then we sub the k into the equation given, and the constant value is k equal to 1 over 3. Sub the k to the previous value, which is a square over x square equal to 1 over 3. And here we got the x value, which is x equal to a over sec 3. Same goes to the y and z. Then we need to find the dimension. So we have 2x equal to 2a over sec 3, 2y equal to 2b over sec 3, 2z equal to 2c over sec 3.